you turn all your y's into x's, don't you? So I'm going to just, on step 2, rewrite x equals 2y plus 1. The third step, solve for y. If we solve this equation for y, we will have an equation that tells us what y is, right? Right now, this tells us what x is. We want it to be what y is. So solve it for y. So I'll do that step 3. I'll do it up here. Step 3, I take x equals 2y plus 1. If I'm going to try and solve for y, it means I want to isolate y. I just take 1 to the other side, right? Subtract 1 on both sides. And then finally, to get the 2 out of the front of y, I divide everything by 2, right? You could say, solve for x back where it was. Yes, you could have, and then switched later. It doesn't matter. This is the way that books do it. This is like the standard. Yeah, it's just the way that it's done in most books. All right. That's step 3. Step 4, oh, sorry, forgot to put the 2. I should divide by the 2, right? Okay. Step 4, replace y with f inverse of x. And that's your answer. So step 4, what I'm going to do is I'm going to write this down, but I'm going to replace the y with the f inverse. But then I'm going to write it backwards. I'm going to put the f inverse first, equals, and then x minus 1 over 2. That's your inverse function. So when I put this problem on the board a minute ago, I just real quickly mentally switched the variable solve for y in my head to come up with this so that I knew I had the right inverse to mess with. See what I'm saying? Now, some problems are not as easy to do that for. It's a pretty simple process, right? I mean, 4 steps, not... Yeah, for 2x plus 1. So let's see it. How about on that one we just did? How about not? Let me think about that. No, we'll do it. So how about this one? Find the inverse. Of f of x equals 2x plus 3 over x plus 4. I can pretty much guarantee you one like this on a test. That's what the little star is over there. Find the inverse. So let's follow the procedure. First, I replace f of x with y. And what do I do next? Interchange the x and y. So everywhere I see a y, I put an x. Everywhere I see an x, I put a y. So it's going to become x equals 2y plus 3 over y plus 4. Now I'm starring this over here, telling you that this is going to be on the test because there's some algebra in here that you need to be able to do. It's not super complicated algebra. It's just not as very natural. It's not as natural as things that you've done in the past, all right? So what is the goal now for step 3? Solve for y, right? Solve for y. So if I'm going to try and solve this for y, that means eventually I need to get y equals something, right? That's what I need. Right now, the problem is that I have y's on the right side in both the numerator and denominator. I need the y to not be in both places. I need it to be all up on top, right? So to do that, I'm going to get rid of the denominator by multiplying both sides by y plus 4. So if I come in here and I take the left side, multiply it by y plus 4. Whatever I do on the left side, I have to do on the right side. And that has the effect of eliminating the fraction on the right side. I'll be able to cancel out these y plus 4. That's why I do it, right? And now what? Let me write down what we have, and then I'll show you what the common mistake is that people make. People will look at this and they'll go, hey, I almost have y by itself. I'm just going to move the 3 over and divide by 2, right? Do you see that that would be maybe something people would want to do? The problem with that is what? You still have y's over here. So even though you have y solved for, you still have y's here. Think about that. That's like, if I'm trying to figure out what y is, I have to know what y is. That's a circular thing, isn't it? Right? If I want to know the value of y, you have to give me the value of y. I'll never be able to find the value of y then, will I? So you must get y isolated completely before you can say it's solved. So you do not try and get this y by itself. What you try and do is release this y from the parentheses. So you have to multiply the x through. Okay, so multiply this x through. xy plus 4x equals 2y plus 3. Now that term that has y in it is free to move around, right? You can move it because it's been released from the parenthesis. So what I'll do now is I'll get all my y terms on one side of the equation, everything that has a y in it on one side, everything that does not have a y in it to the other side. And let's see what this allows me to do. Does what? The long way what?
This is like the longer way? Or I thought we were just doing a common denominator and making it over one.
Common denominator here, which gave us this. But what I was saying is you can't solve for y here because y is over here too.
Yeah.
So you have to somehow get every y on one side. Hang tight, just watch. This is the part, this right here, from here down is the part that makes you, this is why I put this problem on the test. As a college algebra student moving on to do more math, you've got to be able to do this step right here. All right? So I'm going to move both my y terms, this one and this one, to one side of the equation. Everything that does not have a y, which would be this and this, I will move to the other side. So we have some freedom here. Do you want the y's on the left or the right? It's up to you. The left? Okay, so I'm going to leave this one here. I'm going to bring the 2y that's over here to the left, which will make it I subtract it, right? Minus 2y on that side. And then to move a 4x to the right side, I have to subtract it. So I will have xy on the left minus 2y equals the 3 that was over here, right? And then the minus 4x. And you could have written that as negative 4x plus 3. It doesn't matter. Why would I do that?
So now you can divide everything by one.
I have my y's by themselves, but why would I want them by themselves? Go ahead. You can factor out a y. Everyone see that? These both have a y. So pull one y out. Right? This is all just algebra. If this is multiplication, and I don't want all this crap sitting here, I just want the y by itself, I will have to divide that factor out, won't I? So now divide this side by x minus 2, and divide that side by x minus 2. So next step, y times x minus 2 equals 3 minus 4x. I'm dividing this side by x minus 2, dividing this side by, I'll just write x minus 2 like that. Yeah, we'll look at that in a second, Lily. Are there any questions up to this point? Do we have y by itself on the left side? Yes. Does y appear on the right side? No, that's what we wanted, right? We have solved for y. Last step is to replace the y with f inverse. That would give, that you would get full credit if you did that on a test, right? But I want you to notice something. When we did this problem, this was the same function I had earlier that we verified that you have to take home, part of it. It said, when I put that problem up initially, I said verify that these are inverses. I said that its inverse, g of x, was 4x minus 3 over 2 minus x. And we just found that it was this. That's right. So we just all, again, need to make sure that we understand that these are the same thing. So look at the difference. This is positive 4x, negative 3. This is positive 3, negative 4. This is positive x, this is negative x, this is negative 2, this is positive 2. So everything appears to be off by a sign. So watch. What do you want me to do? You want me to turn this one into that one, or you want to turn that one into this one? That's it. Which one do you want? You want me to change that one to this one? You want this one to that one? Okay, so what I'm going to do, I'm going to factor negative 1 out of the top, which changes the signs of what's on top, right? If I pull a negative 1 out. And then on the bottom I have x minus 2. Now a negative 1, when you have a negative on a fraction, the negative can be on the top or on the bottom. Not at both at the same time though, because negative over negative is positive. So what I'm going to choose to do now is make that a positive 1 and insert a negative 1 here. It's just shifting the negative to the bottom. And then pass the negative through here, and what happens? You get the top, which was negative 3 plus 4x, and the bottom, which is negative x plus 2, and then just rearrange the order. Put 4x minus 3, and then put 2 minus x, and then you get this. So it's the same expression, right? Okay, so that's how you verify, or that's how you find the inverse of a function. Make sure you can do that. I believe your homework, there's 1, 2, there are 3 problems like that in your homework to make sure you understand how to do that. Yes?
I just bypassed the whole thing and kept the y sign, right?
You what left?
When going through the steps and everything.
Uh-huh.
Yeah,
You just solved for x? That's fine.
no, I kept the, whenever you were doing the y.
Yeah, I did the opposite. When you move the 2y over,
Uh-huh.
or you move the xy over, I did the 2.
Yeah, so you went to, yeah, you should get the same. Oh, and it matched what they had. Yeah.
It matched the
Yeah,
picture.
so that could determine whether or not yours are going to match the book, but you should be comfortable realizing that yours is the book's answer if you're off by a sign like that. All right, one last thing to talk about. All right, one last short thing to talk about. All right, we saw just a second ago, recall that if we looked at f of x equals x squared, the inverse of that was the square root of x as long as x was inside of the interval 0, infinity, right? We did that one earlier. Okay, I'm going to draw this in detail, and I want to see if you notice something. All right, so here is my y-axis. I am getting serious now. I have a major tendency to, when I write, my writing goes like this. You've probably noticed it, but when I write, everything goes like up like this.
Yeah.
I heard that that's what happy people do. It goes like, but that's not true because I'm not happy. I'm miserable. I heard that. I don't think it's just. It's perspective. When I'm here, this looks straight to me. Does that look straight to you?
No.
Doesn't. See, but for me it does because everything tapers off like that and perspective. It's weird. All right.
That's all right, no offense.
I think that is some color.
Yeah. I'm almost out and need a refill. All right, let's do this. X squared, right, looks like this. When you plug in 0, you get 0. When you plug in 1, you get 1. When you plug in 2, you get 4. And I won't do 3 because I'll be off the chart here, right? So it looks like this. That's x squared. Now the square root of x, you plug in 0, you get 0. You plug in 1, you get 1. You plug in, what's the next one we would know? 4, you plug in 4, you get 2. So let me list out these things because I want you to also see this. 0, 0, 1, 1, 2, 4, 3, 9. These would be the ordered pairs for x squared, wouldn't they be?
Yeah, and then opposite would be
The square root of x, if you listed out those, it would be 0, 0, 1, 1, 4, 2, 9, 3, right? Do y'all see this? Do you see that they're just switched? So like if you graph these, if you flip these ordered pairs over, it's actually the ordered pairs of the inverse, isn't it? And that should make sense because if this x gets turned into y, the other function should take that 9 back to 3. So if 2 goes to 4, 4 should go to 2. 1 goes to 1, well 1 goes to 1, 0, 0, 0, 0. So that's something I'm going to use in a couple of sections from now. When we're trying to graph log functions, we're actually going to use the flipping of the ordered pairs to graph it, all right, which is going to be nice. It's going to work out really clean for us. All right, so now I'm going to graph this. It goes like this. And just so you know, between 0 and 1, x squared is below natural log of x. Natural log of x is above, x squared is below. Once you get past 1, the x squared is above the natural log. All right, now geometrically, does anybody see something about these two graphs? That is good. One is red and one is blue, because they were both looking green to me today.
Perspective.
One is red and one is blue. I wasn't expecting anyone to be able to notice that. That's very good today.
I feel really honored today.
a reflection over x.
Okay, so yeah, there's something, they look almost the same, don't they? I mean, there's,
That's the whole thing.
yeah, so if we were to take this dotted line that goes diagonally, so it goes like this. Now, there is actually a function that is the diagonal. That was the function y equals x, or f of x equals x. That's the identity function, right? If you were to tilt your head sideways so that the identity function is kind of up and down for you, these two look like reflections, don't they? Mirror images of each other over that diagonal. Yeah, don't they? That is always the case when it comes to graphing a function and its inverse. A function and its inverse, when graphed, are symmetric to the identity, are reflections over the identity always. So we can write that down if we want. The graph or graphs of f and f inverse are reflections of each other over the identity. The identity, what is the identity? It's y equals x. Always the case. I'll do another one. You remember I started class with this one. And the inverse of that we showed was x minus 1 over 2, which I hope you also realize is this. Isn't x minus 1 over 2 also 1/2 x minus 1/2? You could split this into two fractions. These are both lines, aren't they? So I could graph both of these, and let me do that. All right. All right, so let me do 2x plus 1 first. So that was a y-intercept of 1, up 2, over 1. So roughly speaking, that is f, isn't it? The inverse function, which I'll do in red, has a y-intercept of what? Negative 1/2. And then its slope is up 1, right 2. So if I go to negative 1/2, so if this is negative 1, negative 1/2 is here, and I'm supposed to go up 1, right 2. Up 1 would be about here. Right 2 would be about here. Something like that. And now if I graph this, like that, get that picture. And if I draw the identity in here, which would be 1, 1, 2, 2, the identity is something like this. I'm a little off here. Missed it. They should intersect each other at the identity, but those look like reflections over the identity to you? Yes? Okay. That's always the case. Any questions? All right, we still have time, but I'm done. So you're free to hang out and do the problem I asked you to do and ask questions, or you're free to go. If you want to turn in, you can. It's fine. All right, have a good day. We'll pick up next class. Hold on, let me verify what we're doing next class.
Are we gonna have
Exponential functions.
Are we gonna have class the day before Thanksgiving?
I have to have class the day before Thanksgiving.
Well, Mileage just said they're giving us